lot of stuff, and please stop me if you have any questions. Okay, I say that it's not. Yeah, I am in Arkansas. Arkansas is very pretty state. So I work with Anna University many years, India, and I like very much your country, but we also collaborate with several institutions from India, and they visit us. And this is our place. I'm just showing you. It's beautiful. Really, is beautiful. It's very small place comparing with the cities in India. So, well, even in small places, I'm sure that everybody has to make a decision, the driving decision every day. So I'm showing you this because this is the typical vision problem that we have every day. And the interesting fact is that actually 90% of information transmitted to the brain is visual. Maybe I can do this, what you want to do. Let me figure out. Is better now? I think it's better for you. Yep. So, yes, and 60,000 faster the visual transformation, visual information is transmitted to the brain. So, but there are, of course, questions like where attention goes, what information is preferable in the situation, or what is the difference between silency and task-driven attention. So most of our studies, you will see in the future, they are about attention, and probably you also are familiar with new models that are in computer vision and in natural language processing that they're related with attention. Okay, so many years I study artificial intelligence for many years, and now I'm absolutely excited because it's everywhere in our communication with robots, with chatbots, and it needs to be mutual comprehensive. Our communication with the artificial intelligence agents. So I'm not going to explain future and past, but it's obvious from the history that even artificial intelligence is a relatively new field. 1956 it's created, but many years actually the development was very slow. But from 2000 you can see from the graph that we're growing very fast. And I really believe, I put some articles here, books, that we can probably go to 4 hours per week work schedule. Some people are rejecting the novelties, some people are excited. So it's a very interesting time to live. And what some articles say, it's actually for industrial revolution. So, okay, we are going, obviously, progress in the technology, but I like the pictures that can we do it anything right, or can we do it better? Yes, there is a interdisciplinary field like a human augmentation that address methods, technology, and their application for enhancing sensing, action, and cognitive capabilities of human. Okay, so we know that the machine will be smart, but my dream is that we have to make people smarter and powerful and enhance the senses, action, and cognitive capabilities. Of course, this area of human augmentation, this market is growing very fast, so we can get the technology like wearable devices that they can help people. Of course, we have a center here, virtual reality center. We do a lot of augmented reality. Exoskeleton are something that we don't have, but some group of people are working and doing. And of course, I will talk more about the intelligent virtual assistant, like the very popular right now. I will ask you your comments about this chat GPT. Okay, so it's growing area, growing market. So I'm giving you just some pictures here that how we start. We start actually with a computer, with gap between the person reality, okay, with R is actually real world, and with C is computer world. So when we start with a regular GUI, we have this gap. Virtual reality, actually, it's you are in computer world, but the reality is outside. Augmented reality, you mix it, and this is good. Okay, these are the examples of augmented reality, by the way. When you have a photo together with some famous author or some food, and this is the augmented reality examples. And you have also cases right now, I think that's more obvious, that the computer world is everywhere, because you have a computer world in your desktop, but you have cell phone or some virtual assistant, or Alexa is talking. So computer world is everywhere, okay? Or so the market, as you can see, in Asia is extremely fast growing for human augmentation. So my studies from many years that we actually trying to simulate the brain activities and create something, I mean, the agent that can perform like a human. But again, people will say, I need better computer, and the computer will say, I need smarter human, So, as I say, we don't need to just go to better technology, but we need to improve ourselves too. And what is interesting, that still the human cognition is the result of interaction of several cognitive processes with limited capabilities. This is true. And another picture I have, and actually, if you want, I will give you the PowerPoint presentation, of course, and there are a lot of good links that are for references that I am using, and for references to our papers. So this paper is extremely interesting because it's showing the difference between what actually current deep learning models can do. We add attention. That is a big novelty in our models. But something that is missing, as you can see, associations, awareness, and self-awareness. This kind of concept, there is no deep learning model or any machine learning model that deals with awareness. Okay, so I borrow from somebody this picture, but I will say that, remember, everybody talks about deep learning models, how they are powerful and they can simulate the brain of small child, and we teach the deep learning models like a child. When the child see the images, can understand the object. Yes, but if you ask one child, for example, is this umbrella can this umbrella cover the elephant from the rain? Can this umbrella make the, it's good for the elephant? And the small child immediately will say no. But like I say, the deep learning model cannot still answer this question, okay? At least for now. Maybe in the future can make this kind of decision, but more complicated decision, deep learning models cannot do it. There is no awareness, there is no association between objects. So they are, and this is also from the paper, and I think that if you are working with deep learning model, you will face these problems, because for supervised learning, for example, to recognize the object, we need thousands of labeled images. And this is the big problem of cause of dimensionality problem, because the error, if you want really not to make a perfect model and have a very low error, you have to have at least 10 of power 9 labeled data. So that's almost impossible, This is the reason that we have so many problems with labeling the data. Many people complain also that it's not explainable. And we have right now in the area of research explainable AI. Difficult to recognize objects with unusual appearance, like these objects, for example. So something that people discuss, and this is the famous GPT-3 language model that is implemented for ChatGPT. So for this model, only for single training session, means one training session, needs an energy consumption of 126 Danish homes. Can you imagine? It's not cheap. It's expensive to run and train deep learning models. This is why we move to pre-trained models. Most popular is BERT, and so on. So there is no algorithm that can resolve all the problems. Like I say, we can have separate algorithms, but not exactly to replace the human, at least in this moment. And yes, the deep learning are good when they are mapping games, but they struggle when the game is slightly alert. Okay, these are also some points that we have to consider. Even that this is the marketing research again, that in 2040, and we're not far away, I will show you here examples that are really good with chatbots and with DALI and with this generative AI. They're close to human performance. They're close. They're really good. So we're moving very, very fast. It's true. There are concern when we move to 2060 that will come with super intelligence, will become being, having conscious self-awareness and high cognitive capabilities. So this moment, we have a lot of discussions, how we can deal with this situation, because will be something unknown. There are a lot of talks, but the suggestion, I recommend you to see this book because I will cite it maybe 2 times or 3 times. Think Fast and Slow by Daniel Kahneman. He's a Nobel Prize winner in 2011. The book is wonderful because we have sensors that perceive the information, and it's fast. But when we deal with decision making, it's a slow process. It's not so fast. And the idea is actually what was before in artificial intelligence. We have mostly symbolic manipulation, symbolic and logic using. But now we concentrate mostly in neural networks, but this is not the solution. So we need to integrate neural networks to solve pixel to symbol problem, and then symbol problems are then handled by a symbol manipulation. Okay, so we need this really fast and slow process. Another idea is that we actually need to integrate right now, currently, actually, the article probably is not so new, but this article is 2020. So integrating, we have a knowledge of neuroscience, and we have knowledge in modeling neural networks, but the property of the word are not included. So these are the missing parts. Also, because our study was mostly about how people perceive information and how they perceive visual information, but it's more obvious that visual and audio information is sequence information. This sequence, and you're working in signal processing, you know this stuff, but it's very interesting that the different sequences, they go to different areas of the brain. So the processing of the information in the brain is not so simple, and this temporal spatial alignment is still open problem in new deep learning models. Okay, I will stop with the brain activities because maybe, I mean, I don't know how interesting it is for you, but the attention models are also based on study of brain activities. And what people call silency is actually bottom-up attention. On what this means, that the information that we try, to extract from the image, it's coming, is a silency actually. But when you have task-driven silency, is attention. There is a difference. So I'm showing you right now what the silency is doing. Silency, you have the image, and this is the first model, very, very basic model Koch created in 2001, that is separating actually 16 different features. And when we group these features together, we actually figure out that somewhere here is the attention. To find out if the silency model is correct or not, we create what we call eye tracking models, where the eye gaze goes. Okay, so most of our studies, I will show you some of them, are related with attention. So this helps us many times with different projects. For example, we want to transmit information, And I am showing you very obvious example. For example, this is in the left image. Left image is actually original photo, but when you compress, you can probably compress only the background and the background is compressed 100 times, and still it's visible because you don't pay attention of far away from your object. So we keep only the objects that are closer to us, and this is the idea of attention, how we use it. We have a patent for this approach, what we call is inverse difference pyramidal decomposition. It's encoding and decoding neural network, but this attention, okay, this is just one application. I'm showing you another application of attention that was also very well accepted, and it is image to text, image captioning. So we have actually several medical schools here, and one of our colleague from medical school asked us how to resolve the problem when the babies, when they sleep, they die. And like I say, we can probably put the device close to the baby, but this is not healthy. So it's extremely important remotely to monitor the baby's sleep. And what they did is very simple with images, but can be done with video. It's very interesting solution. Capture the picture, and as you can see, these areas are actually attention, because the model we use, one of the first models, show, attend, and tell. The first model in natural language processing that is using attention. And when you show the image, we generate the text, baby sleep on the back under the blanket. Please remove the blanket. So this text is automatically generated. And we send this message to the parents, okay? We send this message to the parents, so the parents are, or we can do with alarm or whatever. So this project was a winner in the competition. Like I say, this is the resolving the problem of sudden infant death syndrome for small babies. Very well accepted, one of the first model that we did, and as you can see, also it's not so new, it's 2018 when we did it. So attention we use for, if you are familiar with MASCAR CNN, very famous object detection and object recognition deep learning model. So we have a task to figure out the objects in the X-ray images, and we replace the existing region proposal network, we replace with our attention model. This is another example. So it's our attention model replacing here. So what like I say, what we did, it's also a lot of study with augmenting cognition. Before was augmenting senses, okay? Senses, object detection, object recognition. Now we go to augmenting cognition. Can we understand emotions? Yes, we have studies understanding emotions, and not only these simple emotions that you can see here, but we have studies for depression and for autistic. these kids are autistic kids, so it's more complicated when you have a depression or you have a stress disorder, or you have some kind of more complicated study for emotion. And as you can see, we have here device to measure the brain activities and compare our results with the brain activities, correlation between the results. So this is exactly our study with EEG, EMO EEG. We did, like I say, the gaze control. We have a lot of study about gaze control. And we apply this for drivers. Actually, one of my Indian summer internship student, he did one of the studies about monitoring drivers when they are falling asleep or blinking detection. I'm sure that probably some of you also are working in this area. So cognition. Like I say, we work on a lot of virtual assistants. This project also was a winner of governance competition. It's a chatbot, but with animation, three-dimensional animation. So you can type the text and the chatbot answer with animation your question. For this particularly, also it's not very new. We use it Watson IBM technology in this moment. We did also moving to generative models, but not only to create a new videos, but the study that we did was how we can find the fake faces, fake emotions, fake videos. And this is the popular study also. See, in the fake videos, usually the emotions are not very well represented, or there is a difference between the right and left part of the face, or some small differences that we capture and figure out that they are fake. So again, about attention. With attention of small details, actually we use it like features to create the skeleton. This skeleton, we have a task. I will show you what we did with this, but the task is interesting, from Singapore. It's a older people facilities, okay, and older people health monitoring. So the task was not when people fall down. I have to study too before, many years before this one, falling down. But we don't want to register when people are falling down. We want to predict if they will fall down or develop some kind of changes in the gait movement or posture. This is what these people want. They have a lot of they have a lot of measurements for each person, and what we did is actually monitoring people during 6 months or more, okay, and capture this data every day, okay. We make it the display just to in real time monitoring the skeleton and position of the body, and make this display just to get people excited to go and walk around. But the main idea is when we walk, we capture the skeleton and extract a lot of features. and making a decision if this is the normal or abnormal movement. Yeah? So we use, again, the deep learning model. It's not our model created, but it's an open post architecture. But like I say, the main advantage of our study was that we're doing during over the time. What we do is actually measure the angles of particular joints, and this can show you, for example, when the performance of this joint is walking, it's okay. When there is something wrong, it's a changing the angle, and it's a normal gait for 21 days and change after the 21 day, depending. But this information is integrated with the information of medical records like a blood pressure or more or some particular disease. And as you can see, we monitor a few only features, gait features and posture features. This is what we monitor during time, like I say, not for short time, but 6-9 months. And the project were very well accepted. Actually was, did I mention, is a Nokia Bell project. So, and we get a grant from Nokia Finland for this project. So if I'm moving fast, you can stop me and ask questions. Like I say, we will communicate with robots, and I'm sure that I can see talks for robots and communication, and they're really interesting. For Nokia, what we create actually was interesting idea using the psychology and using Johari window theory of good communication between people. So this theory we need to apply, or maybe it's good to apply, at least this is our suggestion, how we communicate with robots. Because this communication will be not simple. It's necessary. The main idea is actually to extend the open window, means that we understand each other, we include the personalization, you know, and this is the vertical expansion. So we don't want to have bigger hidden area. So bigger means that the robot needs to understand our gestures, our voice, our emotions. So this area, to the robot to know us, it's very, very, very important. And at the same time, we need to understand the horizontal expansion. And this is coming with, obviously, reinforcement learning. And this is why I say, again, we're going to the theory of fast and slow learning. This is abstract concept. I don't know how many people will accept it, but it's still something that we propose. And what for sure, I mean, it's obvious, is that our hypothesis and our future work, we have a lot of work in this area, that people they use multimodal information simultaneously, and we have a multi-attention mechanism. It's not necessary just to get only one attention, you know, but we have a multiple attention mechanism, and we're very good dealing with multi-attention mechanism. That is not exactly included in deep learning models currently, deep learning models. In some of them, yes. So, and the second is very important, that again is coming, like I say, from fast and slow. Humans use system 1 to detect object and extract feature based on previous experience, and use the system 2, the slow thinking system, to determine what information is relevant to solve the task. And I'm giving here the example that is easy to understand. If the man is standing on the sidewalk, okay? So this man, environment for this man is the same. Buildings, cars. So he has the environment and he can extract features, but what is actually attention? What will be important for him? It's related with the task. So if he wants to find a taxi, he will try to figure out yellow color or some sign of taxi. So this will become a relevant feature to solving the task. But if he is crossing the street, the speed of the car will be important feature. And there are a lot of studies, and actually I have the paper and I can recommend you if somebody is interested about exactly this problem, that we have multiple attentions. In the same time, we see the environment, but what kind of features we will select are related with our task in current moment. Okay, so like I say, again, we use this, and maybe some of you also are familiar with neuromarketing research. So all of this human computer interaction and all of these techniques, measurement that we can measure, eye tracking, EEG, emotions, actually we can measure the primer, what is coming from the primer brain, and this is attention and emotions, visual attention, and all of this we can measure. But cognition and making association and making decision and all of this time is a rational brain. So this is what I again mentioned, that something that is coming like a sensor information is fast, and emotions and attention we can measure fast, but making a decision is a slow process. But this neuromarketing, we're currently working on this neuromarketing, and I want to show you, I think that most of you are probably familiar, but this is from one my student. He collects recently all of the generative AI tools, and I can show you chatbot, open AI chatbot, or DALI is text to image. You have text to vision. You have text to audio. You have image to text. This is what we show you. Text to motion. Even brain to text, some models. So if you are interested, like I say, I will give you I can give you the demo of this one, or DALI. It's very easy, but I think that you're familiar. Okay, we will go back when I finish because you're so quiet. This is DALI. It's generating, if you give the text, the opposite of what I show. image generate text, but DALL-E is giving the text and generate images. I can show you this too. So what we don't need, we not skepticism, not be afraid for new technology. And like I say, I actually have a present here for you because I'm deep learning instructor of NVIDIA, and I offer, and my students actually, two of my students also are certified instructors, but because of the difference of the time, I will give you the code. This is the code that you can go to. Let me see if we can go now. You can go. Oops. Oh, we have to stop this. It's working. So these are the classes that are online. Like I say, because we can do the workshop for you if you want, but the time difference. And, so this is why you can do online training. Which one is the online? Not. So you should go to just online, not the workshops. These are the workshops, but you have also this is the self-learning courses. So you can use the code, and instead of some of them are free, but some of them you need to pay $90, $30, something like this. When you go, I have all of them actually. But when you click, there is a area. This directly will go to my, I think, enroll. And in this enroll, I'm already there. There is an area to ask you for the code. And when you put the code, this becomes free, becomes zero. Even that they ask you the information, I hope this works. I'm giving you also links how we can become an ambassador or a certified instructor. I hope that you have this possibility. And of course, you are free to contact me. My email is here. Okay. So we have actually time. Of course, big acknowledgement of my students. I have a lot of PhD and master students that they work with me. And if you have questions, or do you want me to show you a little bit ChatGPT, how it works, or some questions if you have it for some of the work or something that is more interesting. So please feel free to.
Thank you, ma'am. Thank you for your interesting presentation. So now the session is open for queries. So any queries from the participant side? Don't.
Hi, ma'am. This is Anita.
Hi.
Ma'am, I have a question regarding the gait analysis you have said about the human monitoring, elder monitoring health system, right? I just have one curiosity about the how, which part of, or you can consider the vital features, maybe consider to optimize the health monitoring system, just to know. It would be useful for me if I know.
What exactly, what aspect of health we monitor?
Maybe regarding the fall system, you have said about the elderly part.
The falling, yeah.
Yeah.
The falling. Well, like I mentioned, I have a paper with another student that actually capture when person is falling down, but these studies say no, we don't want this. We want to predict if the people change the gait or they change the posture when they are moving. So how we do this? We actually extract the skeleton. Okay, and from the skeleton, it's a very similar idea about facial expression and movements of the body or movements of the hand. All of them, they have a particular key points. And this is, for example, the skeleton of the human. So this skeleton, when we move, normal movements, will create angles, normal angles or abnormal angles. So this is how we monitor the normal and abnormal. So you probably is very small, the curve, but abnormal is blue and normal is yellow. So there are these angles that we calculate, like when you move normally, you have a particular pattern, of movements. But this pattern is like before. Remember that they start investigating Parkinson disease, for example, the movements of people with Parkinson disease. But they have a devices to measure. We don't have a devices. This is absolutely, monitoring from camera only. So this is the advantage of the technology, that if you extract the skeleton, extract the key points, you are able to create the angles of particular joints, depending, like I say, what kind of problem, what kind of health problem we want to resolve. With the Parkinson, maybe will be mostly hands and movements, depending what kind of. And in the falling, they say that this is important for us. Distance phase, asymmetry, swing phase, asymmetry, step length, stride length, low leg angle extrema, asymmetry. So these kind of features are important, and walking speed. So particularly for our problem for falling down, we monitoring every day these features for people. And well, we didn't continue, but another student I have that will continue integrating these measurements, the position of the body and gait features, with blood pressure, and you can predict if this person will improve after the treatment or not. Did I answer?
You're asking a question? Yeah, I have plenty of answers there. I mean, you have given the detailed features, ma'am, exactly what I need. Thank you, ma'am.
Thank you. Thank you. Thank you.
Thank you. Thank you so much.
Okay.
We have few more questions, ma'am.
Oh, sure, sure.
Good morning, ma'am. This is Sangeeta from IT department, MIT. So there was a presentation and a project regarding this extracting the brain features.
Okay.
And I have a small doubt regarding that. Can we get a concrete EEG data set which would be able to process the entire set of features in one shot? And can it do seizure prediction, which would actually aid autistic patients or any children with brain disorders?
So what kind of device do you use? What kind of EEG data?
Yeah, EEG data, that is video EEG data for 1 hour recording during sleep. We have data sets available. So we have done a preliminary work on that. But the problem is we are not able to get or download the entire range of values during one shot. That is the entire video EEG recording, which would run up to 1 hour.
How many channels?
It is 23 channels. And it is actually extracted to, that is down sampled to 18 channels, out of which 9 channels was found fine for prediction. But the accuracy didn't turn up very good. Even we referred IEEE transactions for it. So.
Well, did you present this like an image?
Yes, actually it was the recording, the signals. I'm basically a computer science person. So what we had, the extracted data points available in the data set.
Well, we did. Do you have only 2 classes, normal and abnormal?
Yes, exactly.
Yeah, we did this with but multiple images, training deep learning model to recognize the differences. But in this case, you need a lot of images. I don't know how many you have it, but if you have many, you can train the deep learning model. I think that I can send you the article. My student did it. But she, remember what kind of problem, I think was maybe for Parkinson or some different disease, but was from EEG data set. Can you try with deep learning model?
Yes, ma'am. We have tried with the basic deep learning model, but the results were not satisfactory. So if you can just share me the data set, we'll definitely work on it to have a good
I don't know if I have a data set, but actually
images.
I recommend you. I don't know. Okay, I don't know. Let's see. Do you? I want to ask people. Do you use this Chat GPT? It's famous right now in India, or it's not coming yet?
We have to. Right now it is in boom, so we'll just try to use it and find out the results. But anyways, if we can do it and we can compare the results, that would be fine.
Yeah, but I didn't understand. If you have a Chat GPT, you can ask a question about particular data set and give your answers. And I found a lot of data sets.
Okay, ma'am, sure. I'll try it. I didn't try it.
Yeah, but plus the deep learning model, depending, I say they are not good when you have a small number of images. They are really, they need a lot of images. and it's very tricky also what kind of model you're using. But I will send to Dr. Kumar the paper that my students use with EEG in deep learning model.
Sure, ma'am. Sure, ma'am.
Thank you so much. It's very good study, but EEG records, it's difficult to work with this kind of data.
That's right, ma'am. It was a big challenge.
Big challenge. It's a big challenge.
Thank you, ma'am. Thank you for your input. I'll definitely get it on. Thank you.
Any other queries? I have one query, ma'am. So in order to deploy a deep learning model in real time, so we need to have high-speed computing devices. So in a laboratory point of view, we can train the model using GPUs, but how far it is feasible to implement in a real-time situation, because it will be a little bit costlier when I go for real-time implementation.
No. It's my students even using Raspberry Pi. You have this Raspberry Pi or edge devices, and they deploy it, and they're perfectly fine in real time. They're very good. Plus, I will send you the presentation. You can take a look at the links. What is the course that NVIDIA is doing is actually using NVIDIA server. I use Google Colab. I don't know if you're using in your study, but Google Colab is very good. They have a GPU and yeah, so well, we deploy our models in Raspberry Pi devices very successful.
Okay, ma'am. Thank you, ma'am.
The training takes time. Deploy, it's easy. The training, but please work with, if it's possible for you, you can check the NVIDIA server, work with them, or Google Colab.
Okay. Any other queries? So I think there are no more queries, ma'am.
Okay,
so
I will send you the presentation. Thank you so much.
Thank you very much, ma'am.
Yeah, please feel free to contact me when you have questions or use the code. I appreciate your students and colleagues. They're exciting time right now. It's exciting to work in this area. Thank you so much.
Thank you.
Thank you.